The export controls were supposed to slow China down. Then, a tiny company almost nobody had heard of reportedly helped move more than $2 billion worth of semiconductor equipment into China anyway. Not a state-owned giant, not some famous tech conglomerate, a paper company. The kind of corporate entity that usually exists for tax filings, mailbox rentals, and paperwork nobody reads carefully. Meanwhile, Washington was giving speeches about closing loopholes and protecting strategic technologies. China was still buying machines, which is awkward, because this wasn't happening in the shadows of the internet or through some Cold War-style smuggling ring. A lot of it happened through perfectly recognizable commercial pathways: distributors, intermediaries, leasing structures, third-country subsidiaries, refurbished tools, gray market resellers. The semiconductor industry is so sprawling and so dependent on overlapping suppliers that blocking one route often just creates 3 more expensive ones. And that matters far beyond chips, because semiconductors are not just another industry. They sit underneath almost every modern system people take for granted. Banking servers, AI models, missile guidance, EVs, telecom networks, cloud computing, even basic industrial machinery. A delay in advanced lithography equipment today can shape military balance sheets 5 years from now. That's the uncomfortable timeline nobody can shorten with a press conference. Back in October 2022, the U.S. Department of Commerce rolled out sweeping export restrictions aimed at cutting China off from advanced chip-making capability, especially around AI accelerators and sub-14 nanometer manufacturing. Then came the Netherlands restricting ASML's advanced lithography exports. Japan joined with controls on deposition and etching systems. On paper, it looked coordinated, surgical even, but there was a quiet assumption buried underneath all of it, that the semiconductor supply chain behaves like a pipeline. Turn the valve off in one place and the flow stops downstream. Except it doesn't behave like a pipeline. It behaves like water spilled across a tiled floor. It spreads through every crack available. And over the next 2 years, Chinese imports of chip-making equipment didn't collapse. In several categories, they surged. Chinese firms bought aggressively from Japan, South Korea, Singapore, Malaysia, and secondary distributors operating through Hong Kong. Some tools were older generation systems. Some were legally compliant but strategically useful. Some were likely routed through structures specifically designed to create distance between the original supplier and the final customer. We'll come back to why older equipment matters more than people realize. That detail changes the whole story. The strange part is that none of this was entirely hidden. Customs records, investor filings, and trade databases were flashing signals everywhere. In 2023, China imported record volumes of semiconductor manufacturing equipment. Analysts at firms like Tech Insights and SemiAnalysis started noticing something odd. Despite sanctions, China's domestic fabrication capacity kept expanding faster than expected. Not smoothly, not efficiently, but definitely not collapsing. There's a tendency in Washington to treat sanctions as physical barriers. You ban access, and the system weakens. That logic works better for consumer goods than industrial ecosystems. Semiconductor manufacturing is a layered machine involving thousands of suppliers, decades of accumulated engineering knowledge, spare parts networks, chemical supply chains, maintenance contracts, and technicians who know how to keep old systems alive far beyond their intended lifespan. A chip fab is less like a factory and more like an organism, which creates a problem policymakers still seem reluctant to admit publicly. America doesn't fully control the semiconductor system anymore, even if its companies still dominate crucial layers of it. And buried inside this story is a much bigger question. What happens when a superpower discovers the infrastructure it's trying to weaponize is too globally entangled to obey clean geopolitical lines? The easiest mistake here is assuming the goal was to secretly import the most advanced machines on Earth. It wasn't. That's where a lot of commentary on China's semiconductor strategy quietly falls apart. People imagine Beijing desperately chasing one forbidden EUV lithography machine from ASML like it's the final infinity stone. But the real strategy was broader, messier, and honestly more practical than that. China started buying everything, not just cutting-edge systems, older DUV lithography tools, etching machines, inspection systems, wafer handling equipment, refurbished deposition hardware, spare components, maintenance contracts, entire inventories from secondary markets. If a machine could still produce commercially useful chips at scale, somebody in China wanted it. And that changes the economics completely. Because most global electronics don't actually require bleeding-edge 3-nanometer chips. Cars don't, appliances don't, industrial sensors don't, power management systems don't. Even a surprising amount of military hardware doesn't. Mature node semiconductors, 28 nanometers, 45 nanometers, 65 nanometers, still run huge sections of the global economy. That's the part many policymakers underestimated. They focused on stopping China from reaching the frontier, while China focused on dominating the industrial base underneath it. Those are not the same battle. A good example sits in Shanghai. Semiconductor Manufacturing International Corporation, SMIC, kept expanding capacity even under restrictions, partly because older generation tools remain incredibly useful when deployed at scale. Advanced AI chips grab headlines. Mature node chips keep factories running. And here's the strange irony. Sanctions may have accelerated some of this behavior. Once Chinese firms realized access to foreign equipment could tighten further at any moment, they shifted into stockpiling mode. Equipment orders surged. Companies bought tools they might not even need immediately because future access looked uncertain. One analyst compared it to countries hoarding energy supplies before a winter shortage. Except these machines cost millions each, and sometimes weigh more than a tank. There's also the Hong Kong layer. This is where the paper company angle becomes important, because Hong Kong still operates as a commercial gateway with legal and financial structures that differ from mainland China in important ways. Small intermediary firms could purchase, resell, lease, or broker equipment between multiple jurisdictions, sometimes legally. Sometimes in gray areas, regulators struggled to track in real time. And semiconductor equipment is uniquely difficult to police because individual machines often move through multiple owners during their lifespans. A refurbished etching system sold from South Korea to Singapore, then routed through Hong Kong before ending up in Shenzhen, can create enough administrative fog to slow enforcement dramatically. Not forever, but long enough. The U.S. Bureau of Industry and Security did tighten rules repeatedly between 2023 and 2025. Washington clearly understood the gaps were real. Yet every new restriction created fresh incentives for distributors and brokers to reorganize around them. One compliance lawyer described it bluntly. The market treats regulation like a routing problem. That sentence stayed with me, because it explains why this story feels so different from older sanctions regimes. In the Cold War, strategic industries were more nationally contained. Today, the semiconductor ecosystem resembles a giant multiplayer dependency network. American software relies on Taiwanese fabrication using Japanese chemicals on Dutch equipment with rare earth inputs processed in China. Nobody fully controls it, not even the country writing the sanctions. And there's another layer people rarely discuss openly. Western companies themselves had conflicting incentives. Publicly, firms supported export controls. Privately, China remained one of the largest semiconductor equipment markets on Earth. Billions in annual revenue were tied to Chinese demand. Investors expected growth. Executives had shareholders to answer to. Geopolitics entered the room. Quarterly earnings were already sitting there. To be fair, the restrictions absolutely did hurt China at the cutting edge. Developing advanced AI chips without unrestricted access to top-tier lithography remains difficult, expensive, and slow. That part is real. But the broader industrial picture turned out to be much harder to choke off than many officials predicted in 2022. Remember the assumption from part 1, that the supply chain behaves like a controllable pipeline? By 2024, it was becoming clear the system behaved more like a living market adapting under pressure. And adaptation has a strange side effect. Sometimes, the pressure itself becomes the engine driving industrial independence. For a while, the American assumption was straightforward. Deny China the highest-end semiconductor technology, and eventually the gap widens beyond recovery. Reasonable theory. Historically, advanced manufacturing ecosystems are brutally hard to replicate. ASML spent decades building EUV lithography. Taiwan Semiconductor Manufacturing Company refined fabrication processes through thousands of engineering iterations. Even Intel, with all its resources, stumbled repeatedly trying to maintain leadership at the frontier. So the logic made sense. If China lost access to the tools, the expertise, and the ecosystem simultaneously, progress should slow dramatically. Instead, something stranger happened. The restrictions appear to have compressed China's incentives into a single direction: build domestic capability at almost any cost. Not because Beijing suddenly discovered free market efficiency, quite the opposite. The system became wildly expensive, redundant, and occasionally irrational. Provincial governments threw money into semiconductor funds. Local officials backed projects with little technical viability. Some factories failed outright. Billions disappeared into dead-end ventures. China's chip sector occasionally resembles a national industrial panic attack. But industrial history suggests something uncomfortable. Large-scale overinvestment can still produce long-term capability if enough engineering talent survives the chaos. That's what happened in steel, solar panels, electric vehicles, shipbuilding, and maybe semiconductors too. The reversal here is important. The sanctions were designed to preserve technological distance. In some areas, they may have shortened the timeline for Chinese substitution instead. Not at the frontier. That distinction matters. China still faces major barriers in advanced lithography, high-bandwidth memory, and leading-edge AI accelerators. Manufacturing competitive 3-nanometer class chips consistently remains extraordinarily difficult without unrestricted access to top-end equipment. But the center of gravity may be shifting underneath the debate, because semiconductor dominance isn't only about who makes the single best chip. It's also about who controls volume manufacturing, packaging, mature node supply, industrial resilience, materials processing, and the workforce capable of scaling production during a crisis. That broader industrial layer gets less attention because it's less glamorous. Nobody makes dramatic YouTube thumbnails about power management chips. Yet during the automotive shortages after COVID, tiny, mature node semiconductors shut down assembly lines across Europe and North America. Entire factories stalled over chips cheaper than dinner. Small components, massive leverage. And this is where the paper company story stops being a loophole story and becomes something larger. It revealed a deeper misunderstanding about globalization itself. Washington approached the semiconductor system as if technological leadership automatically translated into supply chain control. But decades of offshoring created something more fragmented than that. American firms dominate critical intellectual property and software layers. Taiwan dominates advanced fabrication. Dutch firms dominate lithography. Japan dominates specialty chemicals and wafers. China dominates parts of the materials chain and increasingly the manufacturing scale underneath it all. The system was optimized for efficiency, not geopolitical containment. Trying to retrofit geopolitical containment onto a hyper-globalized industrial network is like installing walls inside a spider web after the spider already moved in. You can do it, technically. The web still moves. And there's another issue lurking here that almost nobody in politics likes discussing honestly: enforcement fatigue. Export controls sound clean in speeches, but enforcing them requires armies of compliance officers, customs analysts, financial investigators, allied coordination teams, technical experts, and corporate cooperation across dozens of jurisdictions. Meanwhile, markets adapt continuously. A distributor changes ownership. A shipment reroutes through Malaysia. A maintenance contract becomes a spare parts agreement. A used machine gets reclassified. Regulators close one gap and discover two more. Bureaucracies move quarterly. Supply chains move daily. The semiconductor industry has the personality of water. It keeps searching for openings. I'm not saying export controls failed entirely. They didn't. China's AI sector absolutely felt the pressure. Huawei's advances surprised many analysts, but scaling those capabilities remains difficult under restrictions. High-end compute access still matters enormously. But the idea that sanctions alone could freeze a country with China's industrial scale out of semiconductor development indefinitely was probably optimistic from the beginning, especially after one detail people overlooked in 2022. China graduates more engineers every year than most advanced economies graduate students across all disciplines combined. Quantity isn't quality automatically. Fair point. But engineering ecosystems compound over time. Thousands of mediocre projects can still produce hundreds of competent engineers, and sometimes that's enough to move an industry forward. Which brings us back to the tiny company at the center of this story. Because the real significance was never the paperwork itself. It was the warning hidden underneath it. The age where one country could cleanly shut another out of critical industrial systems may already be ending. 47 engineers. Remember that number from the opening? Small teams matter in semiconductors more than people realize. One experienced lithography group can keep aging systems operational years beyond expectations. One packaging breakthrough can offset weaknesses elsewhere. One procurement network can quietly move billions in equipment before regulators fully understand the pattern. Industries this complicated don't move in straight lines. They mutate. And I think that's the real lesson underneath the paper company story. The issue was never just sanctions evasion. It was that the modern industrial world has become too interconnected, too commercially entangled, and frankly, too profitable for clean economic warfare to work the way politicians describe it. The old assumption was simple. America invents the technology, allies enforce the restrictions, adversaries fall behind. But semiconductor manufacturing isn't Manhattan Project-style science anymore. It's an ecosystem built across decades of globalization. Tens of thousands of suppliers, shared research pipelines, engineers moving between firms, equipment resellers operating across borders most viewers will never think about, financial incentives pushing against strategic objectives every single quarter. That system doesn't obey speeches, it responds to incentives. And China understood something earlier than many Western governments did. If access to foreign technology becomes uncertain, redundancy becomes survival. Build local capacity, stockpile tools, buy older machines, train engineers aggressively, subsidize everything, waste enormous amounts of money if necessary. Because from Beijing's perspective, inefficiency is acceptable, dependence is not. I'm still not convinced China fully catches the United States and its allies at the absolute cutting edge this decade. There are genuine barriers there. EUV lithography remains brutally difficult. Advanced memory bottlenecks are real. Taiwan's manufacturing expertise cannot simply be copied overnight. But I also think Washington underestimated how much industrial depth matters below the frontier. The world doesn't run entirely on breakthrough chips. It runs on millions of ordinary ones. And if China secures dominance in mature node manufacturing, packaging, materials processing, and industrial scale output while slowly narrowing the advanced gap, the geopolitical balance still changes dramatically. Not all at once, quietly, gradually. The kind of shift people notice only after dependency already exists. There's a historical irony here too. For 30 years, the global economy rewarded efficiency above resilience. Western firms outsourced manufacturing because it lowered costs and boosted margins. Investors loved it. Consumers loved cheaper electronics. Governments tolerated the strategic risk because the system appeared stable. Then geopolitics returned. Suddenly, countries started discovering that rebuilding industrial ecosystems is much harder than dismantling them. Factories can be moved. Supply chains can't, at least not quickly. Expertise lives inside people, subcontractors, maintenance networks, and institutional memory. Those things don't fit neatly into sanctions packages. One dry observation here. Every major power now claims it wants supply chain independence while depending heavily on somebody else's supply chain. This is apparently the new version of sovereignty. And honestly, I don't think this ends with semiconductors. The same structural tension is emerging around batteries, rare earth processing, pharmaceuticals, AI infrastructure, aerospace manufacturing, even electricity grids. Governments want strategic control. Markets want efficiency. Those two forces are increasingly colliding head-on. My prediction? Over the next 5 years, the US and its allies will keep tightening semiconductor restrictions. But the strategy will slowly shift away from trying to fully stop China's progress. That goal is becoming too expensive and too unrealistic. Instead, the focus will move toward preserving a moving technological lead while reducing dangerous dependencies at home. That's a very different objective. And China, meanwhile, will probably continue exactly what it's doing now, accepting short-term inefficiency in exchange for long-term industrial autonomy. Expensive? Absolutely. Wasteful at times? Definitely. But countries tend to tolerate enormous inefficiency when they believe national survival is involved. The strange thing is that both sides may partially succeed, which means the world is likely heading toward a more fragmented technological order. Parallel supply chains, parallel standards, parallel ecosystems. Less efficient, more expensive. Probably more politically unstable too. All because somewhere along the way, the global economy became so interconnected that nobody could fully control it anymore. Not even the people who built it. If you enjoyed this kind of analysis, subscribe. There's a lot happening beneath the headlines right now, and most of it is far more interesting than the official version.